Computer science and computer engineering are two very similar majors, but have some big differences. For this video, I will assume you've watched my videos on computer science and computer engineering, because those have more detail, and they are linked in the description. To first just put simply, computer engineers focus more on hardware, like computer chips, microprocessors, sensors, etc., while computer science majors focus more on software. But let's look at the similarities in the curriculum of computer science and computer engineering. Now, as you watch these types of videos, be aware that every university is different. You should still do your research on what the classes will be like at the colleges you plan on attending. So first, both majors will take the first introduction programming classes, and these take about a year to complete. These are where you learn the basics of programming, how to write loops, if statements, functions, how to declare an integer, character, array, and so on, usually in Java and/or C to begin. And you'll have lots of programming assignments in these classes to get you familiar with coding. Then they both take discrete math, and I go into a fair amount of detail on this class in the part 1 computer science video, where you learn about graph theory and equations where the variables only assume integer values. They'll both take a computer architecture class where they go into depth about the hardware design of the CPU, or central processing unit. Now, this is more of a computer engineering based class, but again, at various schools I have seen both majors take this. Now, when it comes to math, both majors will take Calculus 1 and 2. Computer engineers will also take Calculus 3 and differential equations / linear algebra. Now, I will include those in computer science with an asterisk. The asterisk means that many schools will require these classes for computer scientists, but some won't. I've seen some where you can replace, especially Calc 3, with something else. They will take linear algebra, but with the differential equations is also dependent on the school. Now on to their differences. Computer engineers take about half of the classes electrical engineers take, including basic circuit analysis courses, some electronics courses. They also take a signal processing course where you analyze the math behind signals such as sound waves or radio waves. For those who hate math, trigonometry, and analyzing functions, that class will not be fun for you. And lastly, they take their embedded systems class, which involves creating projects with something like an Arduino. This is where the hardware programming comes in that you'll hear computer engineers do that computer scientists don't. It involves programming knowledge, but you also need to know circuit analysis. Combine these and you can create a lot of projects, like maybe a basic digital thermometer. This could totally be a project you do, and you see how there's circuitry here, where you use equipment to look at voltages in the circuit, and that's all from your electrical engineering classes that computer scientists would not have a background in. Then it's cut off in this picture, but you see this cord here? This connects to the computer and is how you download your program onto the device. Some of these can read in voltages from a temperature sensor or circuit, which the program that's downloaded would then use to print whatever back to the screen. So maybe your program says if temp is greater than 30, assuming this is Celsius, then print it's hot to the screen. Or maybe you need to do a conversion, so you might have a variable Fahrenheit temp equals the conversion equation from Celsius to Fahrenheit. And you can call those variables whatever you want. These aren't exactly how it's done, of course, but that's the idea. The program or software gets its values from the hardware, like the temperature sensor, and then your program does the math and outputs whatever is needed. Now, computer scientists go on to take design and analysis of algorithms. Computer engineers do learn some algorithms, but computer scientists go into way more depth, including programming and mathematically proving more complicated and famous algorithms, like the shortest path problem, and this is where discrete math comes in. They also take their class on theory of computation. I discussed this as well as being a very abstract course. You learn more proofs and determine how efficiently problems can be solved using an algorithm. It's a math and proofs-based class that involves, again, discrete math. And I'm actually only going to include those two classes. So now let's look at an overview of everything. Both majors take the beginning programming classes, often just computer science or engineering 101 through 3, discrete math, computer architecture, and even a few calculus courses, often all the same depending on the school. Then computer engineers go on to take circuit analysis courses, electronics courses, signal processing, and embedded systems, all of which are taken by electrical engineers. Whereas computer scientists go on to take design and analysis of algorithms and theory of computation, which both involve discrete math. Notice that computer engineers take discrete math, but don't apply it as much, whereas computer scientists really do. And of course, there are more classes. I didn't include assembly language, operating systems, programming languages, and so on. But every school is different, and the big takeaway from this is how computer scientists go on to take algorithms and the theory of computation, whereas computer engineers take all those circuits and electronics classes as well as embedded systems. That's a main aspect of the differences to take into account when deciding. So now I want to answer some questions. First being, who uses more math? Now here's the thing. They both use a lot of math. If you don't like mathematical problem solving, both these majors will be tough for you. As you saw, computer scientists use more of the discrete math though. They use it in their algorithms and computation class because the kind of math performed by computers is discrete math. Computer engineers will use calculus and more of that continuous math that you're used to in their electrical engineering classes. Differential equations model how circuits will behave, and integration techniques are required when doing signal processing because those signals are continuous functions you can integrate. Computer engineers also do a lot of systems of equations because circuits have lots of voltage and current variables. These aren't really tough mathematically, but it is something to be ready for, and it also will involve imaginary numbers. So if you're sitting there thinking, I hate my calculus class, could I handle computer engineering or should I go into computer science? I'd say go with computer science, but honestly you may hate that math they see too. I wouldn't call it easier, just different. You might be able to handle computer engineering, but you won't like a fair amount of your classes that are math intensive that you just gotta get through. It's up to you to understand what you're able to handle. Now everything I've said so far comes with a huge asterisk of does not apply to every student, especially for these two majors, and here's what I mean. Both majors have to take elective courses, and those elective courses can be in each other's disciplines. So if we go back to our list, computer engineers are allowed to take any of these other classes, and ones not listed, as their electives. So they can almost have a degree in computer science too if they wanted. Now computer scientists would not take the electrical classes on the left here. The computer science electives typically would be things like cryptography, game design, software security, computer graphics, and some classes on software engineering. But computer engineers could take these too. Then electives that are often cross-listed as either computer science or computer engineering include autonomous robotics, web development, operating systems, artificial intelligence, database systems, and many more that are just not so simple to understand. Now don't worry about the differences in these two columns so much. Lots of them are pretty much interchangeable, but focus more on what I discussed earlier in this video. But then there are electives that are more computer engineering or electrical engineering based that computer scientists usually would not take, including computer vision and learning image processing methods, digital control systems and how computers are used in control systems, real-time operating systems, computer systems, digital systems design, and so on. Often for these, a prerequisite is the embedded systems class I mentioned before with the digital thermometer, or sometimes the electronics classes that you take. If you're curious about which major has more programming, they are honestly extremely close, but computer scientists typically have just a little more, because computer engineers go off to take circuits and electronics which don't involve programming. But when you factor in elective classes, then a computer engineer could see just as much. Just remember that's not just what these majors are about. If you want a basic real-world example, think of your phone. Lots of engineers have put in work to design that phone. Computer engineers worked on the circuit chips, the memory, the microprocessor, and controls, whereas computer scientists would write the operating system, or iOS for the iPhone users. They write the code for the applications, and come up with the best encryptions to secure our sensitive information. This could apply to video games too, where computer scientists would program the player's movement and all the physics of the game, while computer engineers would make the hardware. So think about what you want to work on when it comes to a career and understand just what you're getting into. Computer engineers are often qualified for software positions, so keep doing research. It's harder to distinguish between these two majors in a career setting. It's not as black and white. Now if you want more detail on discrete math, algorithms and theory of computation, computer engineering classes, or even the math that these majors would take, we have videos for all of them linked below, and it'll give you a much better background than this video because they go into more detail. So that's it for now. Don't forget to like and subscribe, and best of luck on your search.